Hello everybody, this is Mrs. Lindsay. Today I'm going to do an example on a frustum, and this example will consist of surface area and volume. So if you don't have a piece of paper or you haven't printed out the notes, please go ahead and print them out, or again get a piece of paper so you can write this down. Let's first talk about what is a frustum though. Okay, so if we take a look at this diagram here, we initially have a cone. And then what happens is we kind of slice that cone. We take a plane, and notice it is parallel, so it's not a slanted cut. It's just a straight cut through that's going to be parallel to that base. So then it forms a cone on the top, and then what remains once you take off that cone is the frustum. Okay, so if you take a look at this, again, what's really important is that we have a cone on the top, so a smaller cone, and then we have a larger cone. Well, since we know that this is parallel, when it's cut through here, it's parallel, we have a couple different things going on here. So I'm going to draw in some heights here. So this is the height of the smaller cone, then I have a height of the larger cone. We have triangles in the top and then a larger triangle here as well. Well, they both share this angle, and because we know this is parallel to the base, this angle is going to be parallel to that. So now we know the triangle on the top here, using the height and the radius, is going to be similar to the larger triangle, again using the height of this larger cone and the radius. Okay, we're going to use that feature to help us figure out the various slant heights and heights that we need to find the surface area, lateral area, and volumes. Okay, so let's try our first problem here. Here's a frustum. The first thing that we're going to do is find the surface area. So let's talk about how we're going to find the surface area of a frustum. Okay, let me go ahead and move this picture down here just a little bit. And remember, we can extend this up to form our two cones. So now again we have our cone, our larger cone on, our smaller cone on top, and then we have the larger one. So to find the surface area of a frustum, move this down here, we are going to do lateral area of the big cone minus lateral area of the small cone. So again, we're going to take the whole cone, subtract off the smaller one. But now we're going to have to add in the base, the smaller base, and the base on the bottom. So base, I'll just call that on the top, and base on the bottom. Okay, well we can do those right away, but let's go ahead and talk about how do we find the lateral area of a big cone and lateral area of a small cone. Well, if you remember lateral area of a cone, the formula is pi RL. So we need the slant height. We have the radii of both of them already. We have the radius of the smaller one is 7. We have the radius of the bottom, or the larger one, is 12. Okay, so let's go ahead and draw in the height. It's not working here. There we go. So this is our height. Okay, so again, we're looking at triangle on the top versus the larger triangle, and we know that those are similar to each other. Okay, so I'm going to put some markings on here. We know this. Now, it's not the slant height of the larger cone or the smaller cone. It's only a portion of it. Okay, so we know this is 13. We definitely need to find that. So we have the slant height of the smaller cone. So again, we know that this blue triangle and this black triangle are similar to each other. So we can set up a proportion. 7 is to x. Seven is to x. 7 is to x, as 12 is to this whole side, so it'd be 12 is to x plus 13. Now we just have a little algebra problem to do. Cross multiply. 12x equals 7x plus 91 when you do 7 times 13. Solve that guy. 5x equals 91. So x equals 91 over 5. Not a great number to work with, but again, don't round it until the very end. Again, you get a larger rounding error when you do that. But now we have both the slant height of the smaller cone and the larger cone. So let's go ahead and plug this in. So lateral area again is pi. Radius of the larger one is 12. Now the slant height is 13 plus 91 fifths. And you can go ahead and use your calculator on that if you would like. Let's plug that in. Okay, so we have 91 divided by 5 plus 13. And that will give us a slant height. And again, I'm going to, even though that's not rounded, so that would be okay to use, I'm going to use a fraction here, 156 over 5. Fractions are always exact. Minus pi, the radius of the smaller cone is 7, and we know the slant height here is 91 over 5. Plus area of the base, so that's the top base is going to be pi r squared, so 7 squared times pi. Bottom would be 12 squared plus pi. And now I can plug in the whole thing in my calculator, and I'm just going to do the numbers. I'm going to leave pi out right now. So I'll do 12 times, and I'm just going to use my answer key here so I don't have to retype that fraction, minus 7 times 91 divided by 5, plus, now the next one was 7 squared, so that's going to be 49, and then plus 12 squared, so 144, and we get 440 pi. Now that is exact, but if we ask you to round, now at this point in time we can round, so go ahead and multiply by pi, and we're typically rounding to 3 decimal places, so that looks like it'd be 1382.301. So if we ask you again to round, 1382.301, and this would be feet squared. Okay, so exact answer over here. Most of the time we're asking you to round now. Again, follow directions. Always read directions, super important whenever you're doing any homework or assessment. Okay, so let's go ahead and move on to the volume example. Same exact problem. Okay, I'm going to go ahead and move this down just a little bit here so I have a little more room. And volume's going to be a little bit easier on this because we don't have to think about the bases. So volume of the frustum is going to be volume of the big cone minus volume of the small cone. All right, so now volume of the cone, if you recall, is 1/3 pi r squared h. Well, we don't have h. We have, I'm going to go ahead and just draw in what we had from the previous problem here. We had this as 7. We knew this was 12. We found this to be 91 over 5. We now need the heights. Okay, so I'll just call this one y. That'll be the height of the smaller cone. And I'll call this h. Again, that is not the height of the larger cone. Y plus h would be the height of that. Okay, so we can do a little bit of work here. To find y, that one's fairly easy. We're just going to do Pythagorean theorem. Y squared plus 7 squared equals 91 fifths squared. And I know you guys can do that in your calculator. So I'm going to go ahead and just give you the answer for that one, and then I'll show you more calculator work. Again, I'm going to leave it exact as a fraction. I don't want to round until I do the very end. But I get that height of the small cone to be 84 over 5. Okay. So now we know that's what this height is here of the upper cone. Now I need to find h. Well, again, we know this triangle, red triangle, is similar to the larger black triangle there. So we can set up another proportion. So I can do 84 over 5 over 7. So height over the radius equals, again, now this height here, so it's going to be 84 over 5 plus h all over 12. Cross multiply. So here again, if you want me to show you the calculator works, so I would do 84 divided by 5, and I would do times 12. And again, I'm going to leave that as a fraction. So we get that to be 1008 over 5. And then again, I got to do my other calculation, so 84 over 5 times 7. And again, I'm going to leave that as a fraction. That one's going to be 588 over 5 plus 7h. Subtract. And again, that's just a little bit more calculator work, and it happens to work out fairly nicely. You get 84. Divide by 7, and look at this. We get, again, a nice, neat number here. So now we get this height. It's not the height here. It's actually just the height of the frustum. The height of the larger cone is going to be 12 plus 84 over 5. So now when you plug those into our formulas, the big cone is going to be 1/3 pi, radius of 12 squared. Now height is going to again be 12 plus 84 over 5. And I'll go ahead and get out the calculator for that. And I'm going to leave it in exact terms. And we get that to be 144 over 5. Minus cone of the smaller one, 1/3 pi. Radius here is 7 squared. And then again, we found that height there to be 84 over 5. I'm going to do the exact same process with my calculator as I did before. I'm going to do 1/3 times 12 squared, or you can write 144 times 144 divided by 5. I'm going to keep going. Minus 1 divided by 3, I'm putting everything in but the pi's, times 7 squared, or again, you're welcome to write 49 there, and then that was times 84 divided by 5. I'll do math, enter. Looks like I put something in wrong, so let me see what I'm missing. Oh, an extra parenthesis there. Okay, let's try that. 1108 pi, and this is feet cubed. Again, that's exact, but asking you to round. If we did that, we would multiply by pi and round to 3 decimal places. So that looks like 3,480.885 feet cubed. So again, follow directions on whatever you're supposed to do with your homework or assessment. Okay, and this completes the example on surface area and volume for a frustum.